Hours? No. Extra help. Where is this located? This is in my personal drive. There it is. Okay, I'm also going to put a link to this in your Chromebook so that if you want to look at your Chromebook instead of my screen, you can. So let's put this here, and we'll make this folder extra help. Publish. If there was only more hours in the day, I could have this ready for you before you come to school. But here we are. Okay, so this is 01 time. Okay, go ahead and go to day 15, extra help, 01 time, and this will be the document I start from. Now, first things first, we need a problem. So let me grab day 15. Is it not published?
I'm in day 15. I see answer key, complete your study guide, time. Is this first?
Yeah, refresh.
Oh, extra help.
There it is. Thank you, Elijah. All right, so now there's no eating. There are too many ants. What was I gonna do? Let's open it. Open it. I already have it open. Let's get a problem and put that inside the document. So this will go from our lecture. Okay, we'll start with Devin. Read this problem for us.
How long does it take a car to cross a 30-mile wide?
The meter.
Oh,
meter wide.
Intersection after the light turns green if it accelerates from rest to a constant 20 meters.
2.0.
Oh, 2.0 meters
per second squared. So you can just read your screen too, so that it's you can zoom in. Yeah, you can just zoom in, press Control plus, and then it'll get larger. Or you can click the link at the top here, right there. There you go. Let's put that in a pouch. There. You have to go unlock it. I don't know why students lock it. Okay. So there is a car, and it's going to cross an intersection. Let's draw a picture so that it could provide some guidance. So everyone take your pencil and draw for yourself this intersection. And I can give him paper. So this intersection is 30 meters wide. So 30 m. If only this would save. Okay, 30 meters wide. We want to find how long it takes for the light, when the light turns green and the car's crossing the intersection. So that's going to be our time. We're going to solve for t. So everyone take your letter T and put question mark. Okay. What's another variable, Elijah, from our problem that could be something we write down next? So we're on extra help, 01 time, and then it says, how long? Yeah, like pick one of those numbers and make a guess what variable it equals. And then what is 30 going to be represented by? Meters, but what letter in an equation? Because we're going to use an equation. V. No. Meters is distance. So it's going to be either X, D, or L. That's just something you have to memorize. Make a note for yourself. Distance is always X, comma, D, or L. What are you looking for?
Are there any of those,
Erasers?
no,
Sure. I mean, you could use that, but I'm going to say everything out loud. So make a note for yourself on your paper. Distance, Devin, write this down. Devin, distance equals X, comma, D, comma, it might be R also. X, D, R, and L. And L. Devin, can you not eat?
no.
You're just holding it?
Yeah.
You're just holding it? Can you put it away? So we're going to use this equation. This equation is XF. Now, how do you know which equation to use? I'm giving it to you. Okay? Right? XF, everybody. XI plus VI times T plus 1/2 AT squared. How do we know which equation? The teacher says use this equation for this problem. Okay? I would love to explain everything in great detail, but I also have my limits. Okay? So the next time, what's your question? This is A times T squared. So that's acceleration times time with the exponent. So I see where the confusion is. Because sometimes letters look big and small, and they could be either my sloppy handwriting, or it could be what I say it is. So you have to like really match what I say and what I write, which is why I have to do this more often, Aaliyah. I got to go step by step because it could make things worse by just going really fast. Okay. All right. So Elijah says 30 is going to be our distance, right? Our intersection is 30 meters wide, and this car is going to cross. This equation doesn't use D. It doesn't use L. It doesn't use R. But what does it use? It uses X, so we're going to make it an X. And this is not X, just plain old X, like our good old math classes. This is either XF or XI. Aaliyah, what is the difference between XF and XI? Correct. So, final, yes. So there's going to be a distance the car is traveling at the very beginning, and then a distance the car is traveling at the end of this problem. So everyone draw yourself a tiny car like this. Right? And the problem says we want the car to cross 30 meters like that. But the car is also starting from a particular point. We call the starting point VI. And Aaliyah called it initial. Just like your initials can be your first letter of your name, the initial velocity is the speed the car is traveling at the very beginning. Now I went a little ahead of myself. We're talking about XI. So XI is also at the beginning, but it's the distance. So everyone write XI and VI for the car at the very beginning. Now what's nice about this problem is that the distance the car has traveled at the beginning of this problem is zero distance. We're assuming it's at a red light. And the problem says it's at rest. So we're not going to say x equals 30, we're going to say either xf or xi equals 30. Aaliyah, take a guess. Which is the correct type of x? It's either xf or xi. What's the final distance we want for this car? So if you look at our picture, the car is supposed to go 30 meters, right? Elijah helped us see this. So that's the final distance. Make a note for yourself on your paper. XF is final distance. Okay, next is Jesus. Jesus, what is the another number we could plug into our notes and keep track of? Just look at the problem. Are you there? Go to extra help and click on 0 1 time. And look at one of those numbers and tell me what it probably represents. What number hasn't been mentioned? Elijah said 30. What do you see there? You can make your screen brighter if you want. 2. Everyone write 2. 2.00 meters per second squared. Now, Jesus, take a good guess. Does that 2 represent XF, XI, VI, T, A? That's it. 5 variables. What do you think is the best guess in your opinion? T's already taken. Which one? VI. VI is, grab a chair, sit next to Aaliyah. VI is initial velocity. So make a note for yourself on your paper. VI equals initial velocity. And that's the speed the car is going at the beginning. But our problem says at the beginning, the car is at rest. So it cannot be VI. Try again. You either have XI, you have T, or A. Take a guess. A is acceleration, and that's how fast the car is speeding up, and that is 2. Everyone put A equals 2. A is acceleration. Now, how do we know which is acceleration and which one is velocity? Well, acceleration will always have meters over seconds squared. Write that down if you need to remember that. Acceleration will always be in meters over seconds squared. Okay, let's go to Carlos. We have these variables left over. We have VI with no number yet. We have T with no number. And let's see, 1, 2, 3, 4, 5. What am I missing here? XF, XI. Okay. What do you think is going to be? Oh yeah, you need paper too? Okay. So Aaliyah, can you scoot towards Elijah, and then sit next to Aaliyah, Cable's from Marvel. Yeah, go ahead, sit there. And then, do you have a Chromebook? Yeah, take that out. Go to day 15. Extra help. Carlos, VI. What could VI be in our physics problem? What do you think? Or what does it mean, first of all? Aaliyah, help us out. What's VI mean again? Can you say that? Initial velocity. Write that down. VI is initial velocity. Initial velocity. That's the speed at the beginning of the problem. The speed. So it's 0. Good job. Can you give us xi as well? Also be 0. How many of you were also thinking that? VI is 0, xi is 0. How many? Okay, good. How many are wondering why xi and VI are 0? All right. Devin, can you explain why VI, xi are 0?
Because it doesn't say it in the problem, right?
It says rest right here.
Oh, yeah, it does say it.
So that's for the speed and for the distance. When things are resting, like this pencil, no speed and no distance is covered. So 0 for both.
Normally it will tell you, right?
Yeah.
So it'll give you like a number.
Yeah, sometimes it'll say the car is traveling right now at 10 miles per hour. But in physics, we say meters per second. And then you can write VI is 10 meters per second. But we're getting ahead of ourselves, okay? For now, VI, xi are 0 because it's at rest. The problem this time told us that. And I'll give you the same problem on your study guide and the same problem on your exam, okay? No surprises. Okay, what do we do next? Elijah, what do we do next? Plug in. What's our XF? 30. What is our XI? Which is it? 2 has a little a next to it, so we're going to save 2 for over here. XI is something Carlos helped us track. What'd you say? 0. And then plus, and then VI. What's VI? 0. And then T.
Isn't it unknown, so it'll be 0?
Do you agree with him? All right. It is unknown, but unknowns will not be 0. Unknowns are question mark. When it's 0, that's because you assumed it's at 0. Either the problem didn't tell you, like you said earlier, or it did tell us, which is even better. It's at rest. Okay. Plus, almost done, Elijah. What's A? 2, and T is unknown. So what should I write? I could put question mark, or I could put letter T. Yeah. But in your mind, you have to translate that as question mark. And that's what makes this class difficult, is that you have to do so many things in your memory as you do each step. And then don't forget the square. All right, Aaliyah, I'm going to rewrite this problem. Tell me how to rewrite it. What happens when I simplify this? Don't simplify too much. Just give us like what's the next step. Just read it out loud. Like don't solve immediately because we need everyone to be on the same boat. So, can I write 30 again? Okay, and then what? Plus 0. Why did you get 0 from here? Well, how did you know this was 0? I want you to say it. Let's say it was 3. What would this be? It'd still be 0. 0 times 3 is 0. What if it was 11? What if t was 11? What would this be? Still 0. Okay. So class, whenever 0 times anything, life gets easy. It just makes 0. We're just going to write 0 plus 0. And then simplify half times 2. What's half times 2? 1. And what's left over? Do I write anything else? T squared. Good. All right. Caitlin, you have a question? Okay. I'm just going to have you check your answers because I have my plate full right now. Here, check your answers. but you have to check here. All right. What do I rewrite, Caleb? You can stop writing and look at my screen. What do we do with this information? What does it become? Aaliyah, you've been summoned. So there's a recording if it helps to use that. What should I rewrite? So I'm going to rewrite 30 because nothing is happening to 30. Is it a quick question? So you're going to multiply this by 1.1, or to increase, you have to find 10% of this and add it to itself. Sorry, that came in a problem. So just add 3.3 to that. Yeah. You're student 3? Yeah. Okay. All right. Hopefully it didn't get into the other problems of other students. So Caleb, nothing's happening to 30, right? There's no multiplication, no division, so we just rewrite it, right? We rewrite it. But we don't have to rewrite this. We can make it simpler. What should I write, Caleb? Let him figure it out. What is? So what should I write? 30 equals what? We could put 1t, but that's the same thing as just t. Anything else? 2. Good. Jesus, you're up. Solve. How do we solve for t? Let him figure it out. We're going to take turns because I want to help everybody. Okay. Who knows how to solve it? Go ahead. What? Say out loud what we should do. Square root. You know what that means? What is it? What does it look like? No, show me with your hand. What is it? Square root. Okay, good. All right. Solve it, Jesus.
Would the square root cancel out the t squared?
That is why we did it. Did you guys hear that? The reason why we do a square root is to cancel out the square. And you're going to do that a lot on these notes. Okay.
I could do this.
Okay. Okay. So then if I send you to the back, no sleeping. Okay? Go to the back. And then I need you to scoot up. And no eating also. Okay? I need to see what you're working on. And then he's gonna scoot up. Okay, Caleb, you sit up. What'd you get, Jesus? Oh. Does everyone have a calculator? You got one? There's one for you, Caleb. And then I'll grab one.
You don't have to go one missing. Lost.
I can't ignore them, so we're going to do 1 on 4. Okay? But I appreciate the honesty. It's what? Yeah. I mean, try to come earlier. Yeah. It's a process. Did you get something? Yeah. So Devin said earlier that we're going to cancel out the square with the square root. So this just becomes t by itself. But here we have square root of 30. Do you know how to put that in? Read it. Anything else? 5.47. What's after the 47? 7. So if it's a number 5 or higher after the 7, then we round up. So what would it be? 48. Good. And that's how we solve for time. Okay? So Caleb, I recorded all these steps out loud with students helping me. So there'll be a video recording of this. Okay? It's a 25-minute video, but you can